In Lesson 6.4, we will now begin to learn how to solve system of linear equations by using substitution. In the previous lesson, we learned how to solve systems of linear equations by graphing the two lines and seeing where the two lines intersect. And at that xy ordered pair, we would have our solution. In this unit, we are going to learn by substitution. There's two main things that we have to remember when solving systems of linear equations using substitution. I want to stress that it is important, our main goal is to isolate one variable, have one variable by itself on the left side in an equation. If we have this, it's going to make it a lot easier for us to substitute this in. So I ask ourselves, how do we change an equation in two variables, y and x, into an equation that has only one variable? Well, I know in my first equation that y equals 5x minus 2. So if I rewrote this second equation using the first equation, (3x plus 2), well, I know that y is 5x minus 2. So I'm going to go ahead and plug in 5x minus 2 in for y, because my first equation tells me that y equals 5x minus 2. And then we go on to finish out the rest of the equation, equals 22. Now this is something that you have seen many times before. It is just simply solving an equation with one variable. You do have to recall those rules. The rules being, number one, distribute. I forgot the rules. Combine like terms, drawing blank. Number 3, variables on the left. Number 4, constant on right. And our last step would be to multiply or divide. Now when we look here, I know if at any time I have parentheses, then I'm always distributing. So I will go ahead and bring down my 3x. Now I distribute the number on the outside of the parentheses to every number inside of the parentheses. That's 3x plus 2 times 5x, which is 10x, and 2 times negative 2, which is a negative 4, equals 22. So I've now used my first step. Combine like terms. I'm looking for like terms of my same variable or having two same constants on the same side of the equal sign. Well, I look here and I see that I have more than one x. I have a 3x and a 10x. I combine those, which will allow me to have 13x. Bring down my constant, minus 4 equals 22. Looking at the third rule, variables on the left. I look and find my variable. My variable is x. Remember, variables are letters. I look at my equal sign. Is my variable on the left side of my equal sign? And it is. So I can skip step 3 and go on to step 4. Constants on right. I look at my constant, which is a number by itself, -4. Is the -4 on the right side of the equal sign? And I notice that it is not. So in order to move this -4 to the right side, I have to do the inverse of what they are doing in the problem. And because they are subtracting 4, I will add 4. And what I do to one side, I must do to the other. -4 plus 4 cancels out. I bring down what I have not used, which is 13x. That cancels out. And I add 22 plus 4, which is 26. I have my last step, which is multiply or divide. Since they are multiplying 13 times x, I am going to divide. I've got to get x by itself, so I need to divide by everything they are multiplying by. And what I do to one side, I do to the other. 13 divided by 13 gives me 1, which 1 times x is just x. And then 26 divided by 13 is 2. Now I have solved for x in this system of equations. However, I'm still not done because I know I have to solve for x and y. So at this point, you have done the hardest part. You will now use this first solution and plug into either equation. I'm going to pick the equation that has the less amount of numbers to plug it into. So I will come and write down this second equation, and I will solve for my second variable. I solved and proved that x equals 2. So therefore, I'm going to plug 2 in for x. When I use my 5 steps, I know I first distribute, which is 5 times 2 is 10. And my second rule would be to combine like terms. Here I have 2 constants. I'm combining like terms. Y equals 8. So I have now solved for x equals 2, and I also have solved for y, which equals 8. That's a lot of work that we could easily make a careless mistake on. So I want to be sure to check my work. And on homework, we are checking all work. Here, let's check. Checking is the easy part. We take the 2 equations. I have y equals 5x minus 2 and 3x plus 2y equals 22. And remember, you may now use a calculator. And I will plug in. First I want to write, let me back up. I want to write my solution in an ordered pair. I know an ordered pair is x, y. So my solution written in an ordered pair would be 2, 8. Now we are going to check and make sure we did not make any careless mistakes. So 2 is my x and 8 is my y. So I'm going to go ahead and plug in my 8 for y equals 5 and my 2 for x minus 2. Now I'm still using these 5 rules to simplify this equation. So I keep, well, actually I'll just simplify across from left to right. 8 will remain equals 5 times 2 is 10 minus 2. I will still bring down my 8 on the left side. 10 minus 2 is 8. Therefore, this holds true. The ordered pair 2, 8 is a solution for my first equation. We have to now check and make sure that 2, 8 is a solution to my second equation. X is 2. Plug in 2 for x. And 8 is y. Still simplifying from left to right. 3 times 2 is 6. 2 times 8 is 16. And I bring down what's on the right side, which is 22. 6 plus 16 is 22. And I bring down what's on the right side. 22 equals 22. Now you are 100% sure that the ordered pair 2, 8 is a solution to these systems of linear equations.